All right, today's lesson is I'm going to talk a little bit about special quadrilaterals, and we're going to deal with rectangles, parallelograms, rectangles, rhombuses, and squares. So the first thing we're going to do is define basically what a parallelogram is. Well, a parallelogram is a special quadrilateral. The reason being that this quadrilateral is going to have opposite sides parallel. Both pairs of opposite sides parallel. So I'm going to start with a line segment, and then I'm going to put a point up here, and then we're going to create a parallel line to that point, to this line. Perfect. Okay. Then we're also going to do a parallel. Let's see. Well, first thing we need to do is connect these dots, these points, and then we'll do a parallel from this point to this line as well, and we'll construct a parallelogram. There we go. Now, I don't want to see lines, so I'm going to hide these. And then I'm going to go ahead and make segments out of them. And what we have created then is a parallelogram. No matter what I do, that stays, these line segments stay parallel, no matter where I drag this thing. Okay? So I'm going to label these quick, A, B, C, and D. And we're going to look at the properties of this parallelogram. So that is the first property, and it's really the definition of what a parallelogram is. Number one, opposite sides are parallel. So there's our first property. We know that those are parallel. Now I can put little arrows in here to help. Hopefully you just accept it. These are parallel. I can put them in there, but it's kind of going to take us too long. So now here's the other property that's very interesting. Watch what happens when we measure the sides. Not only are they parallel, the opposite sides, but look at the opposite sides measures. You can also see, no matter what I do, those sides stay congruent. So opposite sides are parallel. Number two, opposite sides are congruent. So there's two properties about sides in parallelograms. The opposite sides are parallel, the opposite sides are congruent. All the time. That's always true. Now, let's talk a little bit about the angles. Okay? Let's measure angle A quick. I'm going to measure that angle, and it is 50.14 degrees. And then I'm going to measure angle C. Check this out. I'll bet it's 50.14 degrees. It is. So look at that. Opposite angles are congruent. At least there anyway. So let's find angle D. Well, that's 129.86. Let's find angle B. And that's 129.86. So what can you tell us about, what can we say about opposite angles? Opposite angles are congruent as well. So far we have 5 properties of parallelograms. Or 3, sorry. But there's actually 5. There's another one sitting in front of us that we probably don't see with those angles. I'll give you a hint. if you take any two in a row, two at a time, in a row, what do they add up to? Anybody care to guess? I'll do it quick. (180°). So guess what? These angles are called consecutive. So consecutive angles are supplementary, add up to 180. And sorry about that congruence. So consecutive angles add up to 180. They're supplementary. So we have opposite sides parallel, opposite sides congruent. Consecutive angles are supplementary. Now there's one last one, because I told you there were 5, and that has to do with diagonals. Oops. So if I draw in the diagonals, you can tell that those diagonals are not the same length. Look at them. AC is clearly longer than DB, clearly. So they must not be equal. However, if I put a point right there, you see that? And I measure, and I'm going to call this should be letter E, okay? And I measure the distance of AE, 16.78. Oh, where'd it go? There it is. And I measure the distance of CE. What do you think that distance is going to be? The same. Okay? As well as DE and EB. So what do they do to each other? What do the diagonals do? These are called diagonals. What do they do to each other? Well, they bisect each other. Now is a great time to pause it, soak this all up, pause the video, and think, okay, these are the 5 properties of a parallelogram. And it's always true. Okay, now I'm going to try to add a page, and I can't remember how to do it. Add a page. How do I add a page? Oh, add a page. Okay. So, page 2. Now, we just talked about parallelograms. Now, there is a special kind of parallelogram called a rhombus. And when I hear of a rhombus, the first thing I think of is a kicked over square. Okay? Now, let's see. I got to think about this. How do I want to construct a rhombus here? Oh, I know what I want to do. Rotate. And we'll go 60 degrees. That's easy. Okay. And then I'm going to mark. Nope, don't want to do that. Sorry, I'm thinking here. I'm going to flip this over. Oh, I know what I want to do. There we go. There There we go. Okay, so what I've done then is I have found, or I have made a parallelogram now. Now remember, all those properties are true, but I've also now made the lengths of those sides all to be the same. All these sides are the same lengths. So whatever I do with this manipulation, it doesn't matter. The side lengths stay the same. So in a rhombus, 1 through 5, all properties of a parallelogram are true. Plus, there's some other things here. I better draw in the other diagonal quick. There are some other interesting aspects here. We know that the diagonals are bisected. Again, one is much longer than the other. But check this out. Look at the angle formed. It's 90 degrees. So that means all 4 of these have to be 90 degrees. So the diagonals are perpendicular to each other. Okay, so we got to remember our terms. The diagonals are perpendicular. Okay, what else do the diagonals do? Well, watch this. If I measure angle A, it is 60 degrees. But watch when I measure angle CAB, or sorry, C prime AB. It's 30. So the whole thing is 60, but this is 30. So that means this one's 30. So what do the diagonals do to each angle? Well, let's speculate here. If this is 60, guys, this is 120, right? Because we learned that with parallelograms. However, if this is 120, if we draw the diagonal, look at that. The diagonal bisects that angle. So that is the other property. Diagonals bisect the angles. So not only do they bisect each other, in a rhombus, they bisect each other. Or they bisect the angles, sorry. And they're also perpendicular. They're also 90 degrees. So that's cool. Okay. Can't remember what I did next. What'd I do? Oh, shoot. Where did I find that, guys? Document options. Page 3. Okay. So now the next page is going to be a rectangle. So a rectangle looks like a parallelogram, but we have perpendicular, we have 90-degree angles here. So they're still parallel as well. Parallel. And then we're going to construct perpendicular right there. Get some points. Now everywhere I see a line, I'm going to hide it quick so I can make the segments, and I have my rectangle. Now, what's special about a rectangle? Ooh, I forgot something over here, didn't I? Uh-oh. I forgot something. Number 6 is the sides are congruent. That is the definition of a rhombus. That's what distinguishes it from a parallelogram. I apologize. So that's 7, and that's number 8. The sides are congruent, or in other words, it's equilateral. Over here, For a rectangle now, we know these are all 90 degrees, all these angles. So on a rectangle, all the properties, 1 through 5, parallelogram are still applicable here on 1 through 5. But now we did 6, 7, 8. Now number 9 is all angles are congruent. So before we had all sides congruent for a rhombus, but for rectangle all angles are congruent, and that's called equiangular quadrilateral. Okay? Now, there's one more for a rectangle, and it is probably the most important property out of all of these, to be honest with you, one of the most important properties. If I measure the diagonals, you're going to see that they are equal. So AB is 26.63 and CD is 26.63. So in a rectangle, diagonals are congruent. This is called the Carpenter's theorem. And what that means is carpenters, oftentimes, they need to keep things square, so to speak, or 90 degrees. And to do that, it's much easier to just measure two corners to make sure they're the same lengths. The corner, from corner to corner and corner to corner. That's called the Carpenter's theorem. If those diagonals are equal, we know we got 90-degree angles. Okay? Now, we have parallelograms, we have rhombuses, and we have rectangles. And in all three of these properties are going to be true in a square, because a square is an equilateral and equiangular quadrilateral, which means it's all of the above. It includes everything. So all 10 of these properties are true in a square.